1, 2, 3, foul.
Yo, this is our project, dog.
You want to get another one?
Sure.
A tennis player has to be agile in their movement on the court. An example of this movement can include recovering from sidestepping along the baseline to running forward and chipping a short ball, as seen in the upcoming clip.
Alright, so you can see I sidestep, hit a ground stroke, and then I chip the ball as I'm running forward. So this is what the movement would look like from above, hitting the ground stroke and then chipping the ball as I move forward.
Let's say Dan is sidestepping at 5 feet per second along the baseline. He is currently 10 feet from its center, and the service line is 18 feet away from the baseline. What is the rate of change of the distance between Dan and the center of the service line at this moment in time?
So we know that I'm sidestepping along the baseline at approximately 5 feet per second. We also know that the distance between me and the center of the baseline is 10 feet. Further, we know that the perpendicular distance between me and the service line, the other leg of the triangle, so to speak, is 18 feet. So we have to figure out the hypotenuse, the length of the hypotenuse at this time, which is just a little Pythagorean theorem, radical 18 squared plus 10 squared, and you get radical 424 or 2 radical 106. So now that we know all three distances, and we'll identify those three distances as A, B, and R, we can start solving the problem and finding the rate of change of that distance of the hypotenuse at that time.
Alright, so we know that the general form of the Pythagorean theorem is a squared plus b squared is equal to c squared. However, for the purpose of this problem, we have switched out c for r. When you differentiate this equation in terms of t, you get 2a times dA over dt, which is the change in a, plus 2b times dB over dt, which is the change in b, is equal to 2r times dr over dt, or the change in r, which is what we're trying to find. When you plug in for each of these variables, you get 2 times 18 feet, which is the constant perpendicular distance from the baseline to the service line, times 0 feet per second, because as previously stated, that 18 feet will always be constant, plus 2 times 10 feet, which is the distance that Dan is from the center of the baseline, times 5 feet per second, which is the speed that Dan is sidestepping at, is equal to 2 times 2, radical 106 feet, which is the distance that Dan is from the center of the service line at this time, times dr dt, which is what we're still trying to solve for. Eventually, you will find out that dr dt is equal to 25 over radical 106 feet per second, or 2.428 feet per second. Mama Luigi! Wait. Oh god.